Today's lesson is 5.5, multiple angle and product sum formula. All of today's formulas that will be used come straight from mostly cosine of 2u, where this is basically cosine of u times plus u from the other day, where we get cosine u times cosine squared minus sine u times sine u, sine squared. Now, these are going to be the two most used forms of it down here, because they said, why don't we substitute 1 minus sine squared for cosine squared? And that's where this one came from. We'd have 1 minus sine squared, giving us 1 minus 2 sine squared. Also, the other way would be to substitute 1 minus cosine squared here. We got minus 1 double negative cosine squared, giving us 2 cosine squared minus 1. Starting off, solve the equation with the exact values for 2 cosine of x plus sine of 2x equals 0. Well, you need this angle formula from the other page so that we can solve, because they don't have the same amount of x. So aside from the formula, you'd be stuck in a really hard guess and check. We're going to use this formula right here. 2 sine of u, cosine of u, which in this case is sine of x, cosine of x. And we have to bring down the first 2 cosine of x. Now, what can we factor out? They both have a 2. They both have a cosine of x. So taking 2 cosine of x out, we're left with 1 plus, that looks like sine of x here. And now we set each piece equal to 0. 2 cosine of x is 0. Get this cosine equals 0. And 1 plus sine of x equals 0 gives us sine of x is minus 1. Solving both these pieces using our unit circle. Reminder that cosine values are the x values, where is x equal to 0 right here and here at pi half and 3 pi half. And repeating for 5 pi half and 7 pi half, just for pattern reasons. And sine of x is minus 1 just down here at 3 pi half. And that repeats at plus 2 pi. So putting both of those together, we've got pi half, 3 pi half, 5 pi half, 7 pi half. And trying to find out what is my pattern here. The numerator is the odd numbers, plus 2 pi, plus 2 pi, plus 2 pi. And the denominator stays the same, meaning we have to be halves in order to be staying the same. And so we are really pi half plus 2n pi half, and the 2's cancel to give us pi half plus n pi. So x is pi half plus n pi. Next, we've got cosine of 2x plus cosine of x is 0. Now this has a lot of flexibility in what we can substitute for. However, giving us this cosine of x tells us we want to substitute using the 2 cosine squared of x minus 1, so that we can factor and solve. Because now this looks similar to x squared plus x minus 1, 2x squared, minus plus x minus 1, when we rearrange this, where cosine of x is kind of the x that I was talking about. And now we can factor. So numbers multiply equal minus 2 has equal plus 1 is going to be plus 2 minus 1. And then we need to bring this 2 in front back to give us cosine of x plus 1. And the other one's going to be 2 cosine of x minus 1. Just a reminder, because we can't really have a cosine of x minus half. So we bring the 2 up to get 2 cosine of x minus 1. And now we set each piece equal to 0. So cosine of x plus 1 is 0. Gives us cosine of x equal minus 1. And then 2 cosine of x equals 1, right? Plus 1 to both sides. Divide by 2, we get cosine of x is half. And now solving for the values that were for this. So cosine of x is minus 1 right here. Cosine of x is half in quadrant 1 and in quadrant 4. And so writing our answers out, we got pi, 3 pi, 5 pi. On the right, on the left, we've got 1/3 pi third, and then we got 5 pi thirds. And then if we keep repeating, we got 7 pi thirds and 11 pi thirds by adding 2 pi to our earlier. Now, what's the pattern between these? It might be hard to see at first, but it does look like they have a nice rotation between them. And so putting them in order, pretty similar to what we had before with the odd numbers. Pi is the odd one out, so to make it look better, we're going to give it a third as a denominator. So this is 3/3 pi, and now we have 1/3, 3/3, 5/3, 7/3, and again, this is a plus 2 pi over 3. So again, starting with pi thirds plus 2n pi over 3. And there's our answer. Next, we've got write a trig expression as an algebraic expression. So we're going to treat this like this is 2 sine of 2x. We're just going to rewrite this out as 2 sine of x cosine of x. And now we're going to substitute. And instead of x, we have sine inverse of x, arc sine of x. Right? So this is going to be 2 sine of sine inverse of x times cosine of sine inverse of x. And whenever you see something like this, or even sine of sine inverse, generally that should point you to, we're going to need a right triangle. Because sine inverse of x means some angle has an opposite sine of some angle equals x, which again, that's opposite over hypotenuse is x. So I'm making my opposite is going to equal x, my hypotenuse is going to be 1, and then I can solve for the missing angle. So now I've got b squared plus x squared equals 1 squared minus x squared from each side. And by the way, 1 squared is 1. So I've got 1 minus x squared is b squared, and square rooting each side to get square root of 1 minus x squared. So now with this, right, every time I see sine, I'm just using the triangle and that theta to figure out what is sine of that angle. So sine of the angle is x over 1 for opposite over hypotenuse. So now I'm bringing these down. I get 2 times x over 1. And then cosine of that same, and again, cosine is adjacent over hypotenuse, gives me square root of 1 over x squared, sorry, 1 minus x squared over 1. And then putting it together, we get 2x squared root of 1 minus x squared. And now that is an algebraic expression. Next up is the half angle formula. Now again, part of what we were substituting before, you recognize that we went from cosine of 2x to cosine of x, right? So we can cut our argument in half if you're going the other way, or we can double it. Now the big confusing part with this one is the sign. A lot of people like to take their formula sheet for granted and say, okay, it's always plus or minus. That's not true though. Based on whatever this u over 2 is, for example, let's say we get something like 13 pi 12. Seems random, but this is half of 13 pi 6, and 13 pi 6 is going to have the same values as pi 6, which is on our unit circle. Right? However, 13 pi 12, when we look at it, is actually quadrant 3, and so quadrant 3 would dictate, this would dictate whether we're plus or minus. Well, if it's sine or cosine, it's going to be minus, because this is the negative quadrant, or all students take calc. Tangent's the only thing positive there. Now notice, tangent doesn't even have a plus or minus on theirs. Okay? So, when we get to, that one's more important for homework reasons. During this lesson, most of our examples will come from the positive quadrant. So just a very heads-up warning on that. Sine of 112 degrees, 30 minutes. Right, so this is DMS form, and there's 60 minutes in an hour. So 30 over 60, this is just a fancy way for saying 112.5 degrees, which that's not on my unit circle, so I'm going to rewrite it as half of 225 degrees. And I don't really like degrees because we've dealt with radians so much right? Reminder, 225 is over here. That's actually 5 pi 4. So I'm going to treat this as sine of 5 pi 4 over 2. And now, 5 pi 4 doesn't dictate our sine, but 112.5 degrees does. And 112.5 degrees is somewhere kind of over here in quadrant 2, where all students, so S for sine, tells us that the plus or minus on the outside is going to be plus. And now filling in the rest of the formula, 1 minus cosine of just this top angle, this 5 pi 4, all over 2. Now, we know that cosine of 5 pi 4 is a fraction already. So we're going to end up with this complex compound fraction, pardon me. And so because of that, it's going to be a little tricky with simplifying. So now we're left with the square root of 1 minus a negative square root of 2 over 2 all over 2. And again, we're doing cosine values here. So that's where the sine came from. And now I like to simplify numerator first. So this 1 is going to become 2 halves so that my denominators match. Really small there. So now I have 2 halves minus a negative 2. So this is plus, square root of 2 all over 2. And that's our numerator all over 2 in the denominator under a square root. Now this denominator, generally you can either multiply by 2 on top and bottom, or I like to bring a divide by 2 equals times 1/2 up to the numerator. So that's what I'm doing here. And then we're going to have 2 plus root 2, that's times 1, so that doesn't change. But this denominator, 2 over 2 is 4. And now I'm going to split that square root into 2 pieces so we can simplify, because the square root of 4 is 2, and then the numerator is still 2 square root of the quantity of 2 plus square root of 2. And there's my final answer. A little bit of weird simplifying. Next, one more, cosine of 5 pi 12. So this is, again, 5 pi 6 times half. So we'll just rewrite it as 5 pi 6 over 2. And now, for this cosine, the formula changes a little bit. But again, 5 pi 12, plus or minus, we're in quadrant 1, so everything's positive there. Square root of 1 plus cosine of 5 pi 6 over 2. 5 pi 6 this time is root 3 over 2 negative positive half. So I just need this, and we're off to the simplifying. Square root of 2 halves times my 1 plus negative square root of 3 over 2 all over 2. And now with these 2 halves, I can add 2 minus, and it's a plus a minus square root of 3. We're just going to make it minus all over 2, also over another 2. Fixing my square roots here. And then multiplying by half. Top and bottom simplify. Leaves us with 2 minus root 3 over 4. Fixing my square roots to leave us with 2 minus root 3 over 2. And the numerator is all under a second square root. Feel free to pause the video if you need to catch up on this. Next, power reducing formula. So we can go from sine squared to cosine, cosine squared to cosine, and so on. We've got cosine to the 4th x, and we need it in the first power of cosine. So we're going to rewrite this as cosine squared of x times cosine squared of x. So we can go back to this slide and substitute 1 plus cosine of 2u over 2 4. Now notice the angle doubles when we do this, right? So we're now going to have 1 plus cosine of 2x, not 1x, over 2. And the same thing for the second one. So basically that squared, which is going to mean we have to FOIL it. First outer and last, so 1 times 1, 1 times cosine of 2x plus another 1, equals 2 cosine of 2x, and cosine of 2x times cosine of 2x gives us cosine squared of 2x. And 2 times 2 is 4, so these are all over 4. And I'm still going to have to do it one more time here. So I'm going to separate it quick. So this is 1 over 4 plus 2 cosine of 2x over 4 plus 1 cosine squared of 2x over 4. And now we have to substitute here again. We can also simplify 2/4 and 1/2. So 1/4 plus cosine of 2x over 2 plus, and now we got 1 plus cosine, and it's going to double again from 2x to 4x over 2 all over 4. Last bit of simplifying is to get rid of the double fraction times 4 top and bottom. And this will leave us with 1/4 cosine of 2x over 2 plus 1/4 times 1/2 is 1/8. 1/4 times cosine of 4x, I'm just going to use cosine of 4x over 8. And then 1/8 and 1/4 can add, because this is 1/4 is like 2/8. So we got 2/8 plus 1/8 gives us a final answer. 3/8 plus cosine of 2x over 2 plus cosine of 4x over 8. I prefer it written this way because of the simplifying, as opposed to everything over 8. Like 3 plus 4 cosine of 2x, right? With all of them over 8, this just looks simpler to me. One more, try this one on your own. Now revealing the solve here. Sine squared of x is 1 minus cosine of 2x over 2. Cosine squared, we just did 2 last problem, 1 plus cosine of 2x over 2. And these are conjugate, a minus b times a plus b. So that's going to give us 1/4 minus cosine squared of 2x over 4. Still a problem right there, so we're substituting right away this time. Then we got 1 plus cosine of 4x over 2, all over 4. Then we've got to multiply by 1/4 for simplifying, and this negative distributes to both pieces. So it's not plus, but it's a minus half times 1/4, giving us a minus 1/8. And then minus 1/4 times cosine of 4x over 8 gives us minus cosine of 4x over 8. And 1/4 is 2/8. So 2/8 minus 1/8 is 1/8 minus cosine of 4x all over 8. Product of sum formula are a combination of the u minus v, u plus v times half just to get one sine u, sine v type situation. Now how these are going to work is we're going to look to see what the left side is on the equation. We're going to write the right side then of that formula down, and then we're just going to fill it in and simplify. For example, sine of 5 pi, 5 theta, times cosine of 3 theta. We want to rewrite this as a sum or difference. So I'm looking for which one has the sine, cosine. Going back, sine, sine, cosine, cosine. Here we go. Sine, cosine. And this is the formula I'm going to rewrite. Half sine u plus v plus sine u minus v. Something like that. And now I'm going to plug in, well, what is u, what is v? U is 5 theta, v is 3 theta. So plugging that in. And then simplifying. What's 5 plus 3? I get 8 theta. 5 minus 3, 2 theta. Sine in front. And then I just need to distribute this half because it's still a product with this multiplying. So distributing the half, I get half sine of 8 theta plus half sine of 2 theta. Someone brought up a question, why can't we just call it half sine of 10 theta? You can't add the arguments like that, right? Sine of 30 degrees plus sine of 60 degrees does not equal sine of 90 degrees for our unit circle. So it just doesn't work. Next one, same idea, but with a 5 in front. So the cosine is this formula now. So half cosine u minus v plus cosine of u plus v. So that's what I have written down there. We've got half cosine u minus v plus cosine of u plus v. I actually plugged them in this time as we were going. And so simplifying, we get cosine of negative x plus cosine of 5x And then this 5 times half is just going to become 5 half in front. And lastly, cosine eats the negative because it's an even. And then distributing the 5 half, we get 5 half cosine of x plus 5 half cosine of 5x. Is our final solution. One last problem to go is now the sum to product formula. This one's a little more work than the last one because the question is going to be find the zeros of the function in the interval 0 to 2 pi. The solve is still similar. We're going to rewrite the formula that cosine of 2x minus cosine of 6x is going to be the minus 2 sine of u plus v over 2 times sine of u minus v over 2. And then I plug in, well, what's u and v? U is 2x, v is 6x. So plugging it in, I get minus 2 sine of 8 divided by 2 is 4x. Sine of minus 4x divided by 2 is minus 2x. And then a little note about sine is an odd function, so it throws the negative sign out front to the outside. And then now we have a double negative, which is going to make this 2 sine of 4x sine of 2x. But now we've got to set it equal to 0. So we set it equal to 0. We're setting sine of 4x, forgot an x, equal to 0, and sine of 2x equal to 0. Now there's going to be a clear overlap in the answers, so sine of 4x is going to be the only one we care about. We're just showing you where does sine equal 0? Sine is the y values. So our answers are 0, pi, 2 pi, 3 pi, etc. And we set that pattern as n pi equal to 4x. Now we bring back that 4x. So when we divide both sides by 4, we get n pi 4. Now the question also said we want answers between 0 and 2 pi, but not including 2 pi. So my pi fourth answers are 0 fourth, 1 fourth pi, 2 fourth is going to be pi half, 3 pi fourth, 4 fourth is 1, 5 pi fourth, 6 pi fourth is 3 half, and 7 pi fourth. 8 pi fourth would equal 2 pi, which not a hard bracket means not included. So this is my final answer. And just to tie back in, why didn't we do this one? Well, if 2x equals n pi, right, divided by 2 on both sides, you'll see it's already included in our answer. This is the pi half. So this would be 0, pi half, 2 pi, half is pi, 3 half. And those are already in the answer, right here, here, and here. So I didn't miss them, but they overlapped with sine of 4x equals 0. And that wraps up today's lesson. Feel free to send me an email if you got any questions.